Hello, good morning, friends. So, I welcome you all for the subject Digital Electronics, that is for your third semester. So, in this session, we will be discussing the first chapter of your curriculum, that is Combinational Logic Circuits. My name is Ishwar Kumar Nerade, working as lecturer in EC Department, Government Polytechnic, Mudod. Let's begin. So, in this chapter, this chapter is going to cover the following topics. Very first, we will discuss the introduction to the combinational logic circuits. Next, we will discuss the multiplexers, followed by demultiplexers, decoders, encoders, and finally, we will list the different ICs. Combinational logic circuits. So, mainly here, in digital electronics, all the digital logic circuits are broadly classified into two types. The first one is the combinational logic circuits and the second one is the sequential logic circuits. In your curriculum, the very first chapter is the first type, that is the combinational logic circuits, and in the second chapter we will be studying the sequential logic circuits. Combinational logic circuits are memoryless digital logic circuits whose output at any instant in time depends only on the combination of its inputs. Here, there is a term called as memory here. So suppose if you consider the example of human beings, let's say if he wants to remember the previous history, or if he wants to remember some uh, events that has happened in his earlier life, obviously that event has to be stored somewhere in his memory. The memory is analogous to your human brain. The events and the previous history, so they are stored in the memory. But here, as the combination logic circuits are memoryless logic systems, in the sense they don't have the past history information. At any time, at any time, their output depends only on the combination of inputs. And in other way, you can define the combination logic circuits as these are the logic circuits which are constructed using logic gates. Obviously, logic circuits are constructed using logic gates, and here for any at any instant, for the specified input combination you will be getting a specified output. So so here the combination logic circuits, they need to remember what was the previous output combination and what was the previous output. Let's say, for example, if you consider AND gate as example. So AND gate, as you already know, it consists of two inputs and one output. According to the definition of combination logic circuit, we can say that at any time the output, let's write the logic symbol. Let's say this is an AND gate. So it consists of two inputs and one output. So with two inputs, obviously I can have four different combinations like 0, 0, 0, 1, next 1, 0, and 1, 1. As you already know that the AND gate output is 1 only when the input combinations are 1. So means to say that, so for the fourth combination of input, that is 1, 1, inputs for 1, 1, I will be getting a result output as 1. For the rest other input combinations, I will be getting an output 0. So here, let's say that, so these are the inputs, these are the sequence of inputs. You can say 0, 0, 0, 1, 1, 0, and 1, 1. According to this definition, so whenever we give the inputs as 1 and 1, we will be getting the output 1. So it is not compulsory that we should begin inputting right from the sequence 0, 0. Or let's say, for example, let's say if you have given an input combination 0, 1, obviously it is going to produce an output 0. So ನೀವು ಯಾವಾಗ ಏನು ಇನ್ಪುಟ್ ಕೊಡ್ತೀರಾ, ಇನ್ಪುಟ್ ಕೊಡೋ ಕಂಡೀಷನ್ ಏನಿರುತ್ತೆ, ಇನ್ಪುಟ್ ಕಂಡೀಷನ್ಸ್ ಏನಿರುತ್ತೆ ಅದರ ಮೇಲೆ ಮಾತ್ರ ಔಟ್ಪುಟ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಫಸ್ಟ್ 0 1 ಕೊಟ್ಟೆ, 0 ಔಟ್ಪುಟ್ ಬಂತು. ನೆಕ್ಸ್ಟ್ ನಾನು 1 0 ಕೊಟ್ಟೆ, ಅವಾಗ ಮತ್ತೆ 0 ಔಟ್ಪುಟ್ ಬಂತು. ಈ 1 0 0ನೇ ಯಾಕೆ ಬಂತಪ್ಪ ಅಂದರೆ ಬಿಕಾಸ್ ಇನ್ಪುಟ್ ಕಾಂಬಿನೇಷನ್ 1 0 ಇರೋದ್ರಿಂದ 0 ಬಂದಿದ್ದು ಹೊರತಾಗಿ ಪ್ರೀವಿಯಸ್ ಆಗಿ ಅದಕ್ಕೆ 0 1 ಕೊಟ್ಟಿದ್ದು 0 ಬಂದಿತ್ತು, ಅದಕ್ಕಾಗಿ ಇದು 1 0 ಬಂತಪ್ಪ ಅಂತ ಹೇಳಿಕ್ ಬರಂಗಿಲ್ಲ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಹಿಸ್ಟ್ರಿ. ಲೆಟ್ ಸೇ ಫಸ್ಟ್ ಸೀಕ್ವೆನ್ಸ್ ನೀವು 0 1 ಕೊಟ್ಟು ನೆಕ್ಸ್ಟ್ 1 0 ಕೊಟ್ಟಿದ್ರೆ 0 1 ಅನ್ನೋದು ಹಿಸ್ಟ್ರಿ ಆಗ್ಬಿಡುತ್ತೆ, 1 0 ಅನ್ನೋದು ಪ್ರೆಸೆಂಟ್ ಕಂಡೀಷನ್ ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ ಪಾಸ್ಟ್ ಕಂಡೀಷನ್ ಅಂಡ್ ದಿಸ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಕಂಡೀಷನ್. ಪಾಸ್ಟ್ ಕಂಡೀಷನ್ ಏನಿತ್ತು ಅನ್ನೋದು ಬೇಕಾಗಿಲ್ಲ. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ದ ಔಟ್ಪುಟ್ ಎಟ್ ಎನಿ ಇನ್ಸ್ಟಂಟ್. It only depends on the present input combination, not on the previous history. So this is the beauty of combinational logic circuit. Whereas in case of sequential logic circuits, so in opposite to this kind of circuits, they have something called as memory. So here in case of sequential logic circuits, at any instant the output not only depends on the present input combinations, but it also depends upon the previous history. Means, so ನಾವಿಲ್ಲೇ ಆ್ಯಂಡ್ ಗೇಟ್ ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ಮಾಡಬೇಕಾದಾಗ ಹೇಳಿದ್ವಿ, ನಾವು ಫಸ್ಟ್ ಬೇಕಿದ್ರೆ 1 1 ಕೊಟ್ಟಾಗ 1 ಬರುತ್ತೆ, 0 0 ಕೊಟ್ಟಾಗ 0 ಬರುತ್ತೆ. ನೀವು ಯಾವಾಗ ಕೊಟ್ಟರು, ಏನು ಇನ್ಪುಟ್ ಕೊಟ್ಟರು, ಪ್ರೆಸೆಂಟ್ ಇನ್ಪುಟ್ ಏನು ಕೊಟ್ಟಿರ್ತೀರ ಅದರ ಮೇಲೆ ಮಾತ್ರ ಔಟ್ಪುಟ್ ಡಿಸೈಡ್ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಸೀಕ್ವೆನ್ಷಿಯಲ್ ಲಾಜಿಕ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಲೈಕ್ ದ್ಯಾಟ್. ಸೊ ಲೆಟ್ಸ್ ಸೇ 0 1 ಕೊಟ್ಟಾಗ 0 ಬಂದಿತ್ತು, 1 0 ಕೊಟ್ಟಾಗ ನಾವು 0 ಅಂತ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳಿಕ್ ಬರಂಗಿಲ್ಲ, ಅಥವಾ 0 ಅಂತ ಬಂದಾಗ ಇಟ್ ನಾಟ್ ಓನ್ಲಿ it is predicted based on the present input combinations, but the previous history was also considered. Previous history ಕೂಡ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ನ ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಯಾವುದರಲ್ಲಿ? sequential logic circuits. So more about sequential logic circuits we will be studying in the second chapter. So as of now, in combinational logic circuits, you should remember that these are memoryless systems. Memoryless, memory ಎದಕ್ಕೆ ಬೇಕಪ್ಪ ನಮಗಿಲ್ಲಿ? So whenever we want to remember the things, or whenever you want to remember the past history, that past history has to be stored somewhere. Memory in the sense that is a kind of storage. A storage where we will be storing the past history. Past history ಅಂದ್ರೆ ಏನಿರುತ್ತೆ? ಪ್ರೀವಿಯಸ್ ಕಾಂಬಿನೇಷನ್ ಏನು ಕೊಟ್ಟಿದ್ರಿ, ಪ್ರೀವಿಯಸ್ ಕಾಂಬಿನೇಷನ್ ಏನು ಔಟ್ಪುಟ್ ಬಂದಿತ್ತು. So you need to remember the things. So human beings, they remember the things in their brain. So whenever they want to predict new things andaga, so automatically whatever the item, whatever the data that is stored in the brain, that will be brought into picture. In the similar sense here also, whenever in case of sequential logic circuits, whenever the output is to be predicted, whatever the previous history information that was stored in the memory, that will be brought into picture. That past history as well as the present input conditions, both are going to predict the output. But in case of combinational logic circuits, only the present input combinations or present input conditions are considered for predicting their output. Okay, these combinational logic circuits do not use any memory, as I said you, as I told you. So since I don't need to store the previous history, I don't need any memory here, and the previous state of input doesn't have any effect on the present state of circuit. For example, ಇಲ್ಲಿ ನಾವು ಆ್ಯಂಡ್ ಗೇಟ್ ನೋಡಿದಾಗ 1 1 ಕೊಟ್ಟಾಗ ಔಟ್ಪುಟ್ ಏನು ಬಂತಪ್ಪ? 1 1 ಅಂತ ಬಂತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ 0 0 ಕೊಟ್ಟಾಗ ಔಟ್ಪುಟ್ ಏನು ಬಂತು? 0 ಬಂತು. ಸೊ ಪ್ರೀವಿಯಸ್ ಕೊಟ್ಟಿದ್ದೇನು? 1 1 ಕೊಟ್ಟಾಗ 1 ಬಂದು, ಈಗ 0 0 ಕೊಟ್ಟಾಗ 0 ಬಂತು. ಓಕೆ, ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ತಗೊಳ್ಳೋಣ. ಫಸ್ಟ್ 1 0 ಕೊಟ್ಟೆ, ಆಮೇಲೆ 0 ಬಂತು, ಮತ್ತು ಏನು ಮಾಡಿದೆ? ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ 0 0 ಕೊಟ್ಟಾಗ ಮತ್ತು ಏನು ಬಂತು? 0 ಬಂತು. ಇದರ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರೆ, ಫಸ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ನಾನು ಫಸ್ಟ್ 1 1 ಅಂತ ಕೊಟ್ಟಿದ್ದೆ ಕಾಂಬಿನೇಷನು, ಸೆಕೆಂಡ್ ಕೇಸ್ನಲ್ಲಿ ಫಸ್ಟ್ ನಾನು 1 0 ಅಂತ ಕೊಟ್ಟಿದ್ದೆ. ನೀವು ಫಸ್ಟ್ ಕೇಸ್ ಏನಾರ ಕೊಡ್ರಿ, ಬಿಕಾಸ್ ದ ಪಾಸ್ಟ್ ಹಿಸ್ಟ್ರಿ ಡಸಂಟ್ ಮೇಕ್ ಎನಿ ಎಫೆಕ್ಟ್ ಅಂದಾಗ, ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ನಾನು ಆಸ್ ದ ಡೆಫಿನೇಷನ್ ಇಟ್ ಸೆಲ್ಫ್ ಸೇಸ್ ದಟ್ ಅಟ್ ಎನಿ ಟೈಮ್ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಓನ್ಲಿ ಆನ್ ದಿ present input combination ಅಂದಾಗ ಪ್ರೀವಿಯಸ್ ಹಿಸ್ಟ್ರಿ ಡಸಂಟ್ ಮ್ಯಾಟರ್. You can give any input combination in the uh, previous time. So that doesn't make any effect on here, any effect on the present output here. So obviously, how do you fetch the past history? How do you fetch the past history? Obviously, there should be some path. So this is the feedback. This is nothing but this is called as feedback. So feedback ಅಂದ್ರೆ ಏನಪ್ಪ ಇಲ್ಲಿ? ಸೊ ಪ್ರೀವಿಯಸ್ ಹಿಸ್ಟ್ರಿ ನಾನು ಏನ್ ಮಾಡಬೇಕು, ಐ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ಅಂತ ಹೇಳಿದೆ. ಸೊ ಹೌ ಡು ಯು ಗಿವ್ ದ ಪ್ರೀವಿಯಸ್ ಹಿಸ್ಟ್ರಿ ಬ್ಯಾಕ್ ಟು ದ ಇನ್ಪುಟ್ ಸೆಕ್ಷನ್? So there is a path that is nothing but feedback path. So feedback will be directly from output to input. So as I don't need any previous history information, I don't need feedback path also. For example, ನಾ ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡ್ತೀನಿ. ಸೊ ಇದೊಂದು ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಇನ್ಪುಟ್ ಅಂಡ್ ದಿಸ್ ಈಸ್ ದ ಔಟ್ಪುಟ್. ಲೆಟ್ಸ್ ಐ ವಾಂಟ್ ಟು ನೋ ದಿ ವಾಟ್ ವಾಸ್ ದಿ ಔಟ್ಪುಟ್. ಸೊ ಔಟ್ಪುಟ್ ಏನಂತ ನನಗೆ ಬೇಕು. ಸೊ ಬೇಕಂದಾಗ I should provide a physical connection from output to input. So this is nothing but the feedback path. So as in case of combinational logic circuits, I don't need to remember the history. I don't need to remember the previous history. I don't need the feedback path also. Thus, what all are the constituents of combinational logic circuits? Obviously, it consists of only the input variables as input variables and the logic gates as well as the output variables. That's it. So here let's erase all this. So here you have been given a block here. In this block you can clearly see here left side, whatever you can see in the left side is nothing but, so these are the input variables. So as I told you, it consists of input variables. So in this block you can see the left side, whatever I have shown, x1, x2, x3, so on up to xm. There are totally m number of x variables are here, which are shown in the left side of the block here. And you can have the output variables as the constituents here. So here you can see y1, y2, y3, so on up to yn. So these are the output variables. So usually it is a good programming, it is a practice that, so in whenever we are concerned about the logic symbol, usually all the input variables are shown at the left hand side of the block and the output variables are shown at the right hand side of the block. Next you can ask me a question, where are the logic gates, sir? So logic gates are generally, they are used to do a certain function. For example, AND gate that is used to do a multiply function, OR gate that is used to do an addition function. So like this, this is the block which is going to do a certain function. Let's say f is the function name here. Okay. So as in the above figure, as I told you, x with a set of m input variables, that is x0, x1, x2, x3, so on up to xm. And let y be the set of n output variables, y0, y1, y2, so on up to y1, yn. Let f be the combinational function that operates. What this function does, it operates on the x variables and produce the output variable y. Okay. Let f be the combinational function operate on set of x to produce an output variable y. So now, so if you have been asked to write the relationship between the output and input, you can obviously write from the mathematical function, that is y will be equal to some function of x. So what that function may be anything, some function of x. So here I can simply write it as the relationship between inputs and outputs can be expressed as y equal to f of x. Okay. Now, what are the examples of combinational logic circuits? So as we discussed in the first slide, that is a overview of the chapter. So multiplexers, demultiplexers, code encoders, decoders, these all are combinational logic circuits only. So if you have been asked to write the examples, so these can be classified into subsections like arithmetic and logic functions. You can have the adders, subtractors, comparators, and programmable logic devices. Data transmission. In data transmission, you can have the multiplexers, demultiplexers, encoders, as well as decoders. There are some code converters are also there. Binary to decimal decoders, or decimal to binary encoders, BCD to decimal decoders or encoders, or BCD to 7 segment decoder. So these are the code converters and data transmissions, as well as the arithmetical logical functions. Or simply you can write the names as multiplexers, demultiplexers, encoders, decoders. These are the examples for combinational logic circuits. In your examination, you will be asked a question on describe and writing the definition of combinational logic circuits, as well as you will be asked to write the examples for that. So that will be totally a 5 marks question. First you have to write the definition for it. After that you have to write this block. Then you have to express with an mathematical function. Then you are supposed to write the examples. So in this chapter we will be studying further from here onwards. We will be studying the different types of combination logic circuits one by one. Among them, very first one is nothing but the multiplexers. What are multiplexers? Simply I can write multiplexers. These are the kind of combinational logic circuits which selects one of the inputs according to the binary inputs applied on the select lines of the combinational logic circuit, and passes that information on the selected data line to the common output. This is a quite cumbersome definition initially. So first ನೋಡಿದಾಗ ಏನೋ cumbersome ಅನ್ಸುತ್ತೆ, but actually ಏನಪ್ಪ multiplexers ಅಂದ್ರೆ these are the combinational logic circuits. So simply I can tell it is a combinational logic circuit which has many inputs many inputs and single output, many to one, or you can say many to one. So as I told you, in any the constituents of any combinational logic circuits are the input variables, the output variables, as well as the logic function. So here it consists of many inputs. Many inputs means there will be plenty number of inputs will be there for this circuit, and there will be only a single output will be there. So remember here, many inputs andaga I cannot write any random number here. There is a specific number of inputs are provided. There are some specific numbers of inputs will be there at any time. So that specific number will be nothing but many andaga, that will be it will have 2 to the power of n inputs. But remember, there will be only a single output. 2 to the power of n inputs, and there will be only single output. So ಇದನ್ನ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಮುಖಾಂತರ ನಿಮಗೆ ಹೇಳಕ್ಕೆ ಬಯಸ್ತೀನಿ ನಾನು. Let's say in the communication system or in the telephone call, let's say there are 10 callers are there, and all 10 callers are making a call to a single person. So all will be dialing the same number from their phones, but the thing is, all the 10 people cannot talk to the same person at simultaneously. Even though they have made a call to the single person, 10 ಜನ ಸೇರಿ ಒಬ್ಬರಿಗೆ ಕಾಲ್ ಮಾಡಿದಾಗ 10 ಜನರದ್ದು ಕಾಲ್ ಕಲೆಕ್ಟ್ ಆಗಲ್ಲ. 10ರಲ್ಲಿ ಯಾರ್ದಾದ್ರೂ ಒಬ್ಬರದು ಮಾತ್ರ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ. ಯಾರದು ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಅವರು ಮಾತ್ರ ಆ ವ್ಯಕ್ತಿ ಜೊತೆ ಮಾತಾಡ್ಬೋದು. ಕರೆಕ್ಟಾ? ಸೊ ದಿಸ್ ಈಸ್ ಅ ಕೈಂಡ್ ಆಫ್ multiplexer is a kind of data selector. Here you can say here these are the data selectors. So ಇದರ ಅರ್ಥ ಏನು? You will be having plenty number of inputs available. Options ಭಾಳ ಇರ್ತವೆ. So this is like an MCQ in the sense multiple choice questions ಇದ್ದಂಗೆ. There will be 2 to the power of n options will be there, but I cannot select all the 2 to the power of n options simultaneously. I can select only one option, which is the right one. ಇಲ್ಲಿ ಕೂಡ ಹಂಗೆ. So this is the combinational logic circuits which will be having 2 to the power of n data inputs. So 2 to the power of n data inputs ಇರ್ತವೆ. ಸೊ ಯಾವ 2 to the power of n inputs ಎಲ್ಲಾನು ಔಟ್ಪುಟ್ ಲೈನಿಗೆ ಹೋಗೋಕ್ಕಾಗಲ್ಲ. ಈ 2 to the power of n inputs ನಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಇನ್ಪುಟ್ ಮಾತ್ರ ಔಟ್ಪುಟ್ ಲೈನ್ ಮೇಲೆ ಅಪಿಯರ್ ಆಗ್ಬೇಕು ಅಥವಾ ರೂಟ್ ಆಗ್ಬೇಕು. ಸೊ ಯಾವ ಲೈನ್ ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ 2 to the power of n ಇನ್ಪುಟ್ಸ್ ಲೈನಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಲೈನ್ ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ. ಈ ಲೈನ್ ಯಾವ್ದು ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಡಿಸೈಡ್ ಮಾಡೋದು ದ ಇನ್ಫಾರ್ಮೇಶನ್ ಆನ್ ದಿ ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್. ಸೊ ಇದಕ್ಕೆ 2 to the power of n ಇನ್ಪುಟ್ಸ್ ಇದ್ದು ಒನ್ ಔಟ್ಪುಟ್ ಇರುತ್ತೆ. ಈ 2 to the power of n ಇನ್ಪುಟ್ಸ್ ನಲ್ಲಿನ ಯಾವ್ದಾದ್ರು ಒಂದು ಇನ್ಪುಟ್ ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ದೇರ್ ವಿಲ್ ಬಿ n ನಂಬರ್ ಆಫ್ ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್. ಸೊ based on the information on these n number of select lines, out of 2 to the power of n input lines, only one input line will be selected at any time. So whichever the input line that is selected, its information will be routed on the a single output line. Correct? So ಈಗ definition ಇನ್ನೊಮ್ಮೆ ಓದೋಣ. It is a combinational logic circuit which selects one of the inputs ಅಂದ್ರೆ out of 2 to the power of n inputs, only one input will be selected based on what? Based on the binary inputs applied on the select lines. So ಈ input information ಮೇಲೆ ಸೊ ಇದು ಯಾವುದಾದ್ರೂ ಒಂದು ಲೈನ್ ಸೆಲೆಕ್ಟ್ ಆಗಿ and that information, the information on the selected line is passed on the output line, okay. So in the second point we will be mentioning here, so how many inputs are there and how many output will be there, and how many number of select lines will be there. So that number will be given here. So you can see here it is a combinational logic circuit which has maximum 2 to the power of n data inputs and n number of select lines and single output line. This is very important. The inputs may be 2 to the power of n. 2 to the power of n, n here can be 1 2 3 whatever. Let's say if you put n equal to 1, 2 to the power of 1 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ 2. So 2 is to 1 ಅಂತ ಇರಬಹುದು. So you can write ಅದನ್ನ ನಾವು ಬರಿಬೇಕಾದ್ರೆ ಯಾವ ತರ ಬರಿಬಹುದು, 2 is to 1 ಅಥವಾ ನೀವು 2 to the power of n is to 1 ಅಂತ. This is the symbolic notation. Or sometimes some people will write like 2 to the power of n cross into 1 ಅಂತ ಬರೀತಾರೆ. With n equal to 1, if you substitute n equal to 1 ಅಂದಾಗ 2 to the power of 1 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ 2. So you can call the multiplexer system as 2 is to 1 mux. The short form is mux ಅಂತ ಕರೀತಾರೆ, mux mux. ಅಥವಾ if n equal to 2 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ 2 to the power of 2 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ 4 is to 1 mux ಅಂತ ಇರಬಹುದು. There can be, if you substitute n equal to 3, 2 to the power of 3 andre 8 is to 1 mux, like this. So it grows on. So here why these are referred as data selectors. So you can see here clearly from this picture. So this is the output line, single output line, and these are the 2 to the power of n input lines. So your logic function here, this acts like a data selector. So you can see here a switch here. This switch can at any time, this switch can be placed at any one position. Let's say there are n input variables are there. Let's say if the information is so let's say if the switch position is at this point, e point nalidre the input line I0 is selected. Input line I0 is selected andaga the information, whatever the information that is there in the I0 will flow through this switch and it is routed through this output line Q. Understood? Similarly, if this switch is positioned at the last point here, last point ಗೆ position ಬಂದಾಗ let's say ಇಲ್ಲಿ ಒಂದು position ಬಂತಪ್ಪ ಅಂದ್ರೆ ಈ switch, so obviously ಅವಾಗ ಏನಾಗುತ್ತೆ, the information on the last line, the information on the last line is routed and is routed into the output line through the output line Q here. How about others? I cannot make a selection, multiple selection here. I cannot simultaneously select the I0 and I1 together. Either I can make a choice of I0 or I can make a choice of I1. This is like a multiple choice questions. So this is like multiple choice question andre at any time you can make only one selection. So which line is to be selected, that depends upon these select lines. ಸೊ ಈ n ನಂಬರ್ ಆಫ್ ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್ ಏನಿರ್ತಾವಲ್ಲ ಇದರ ಮೇಲಿರುವಂಥ ಇನ್ಫಾರ್ಮೇಶನ್ ತಿಳ್ಕೊಂಡು ಇದರ ಮೇಲಿನ ಇನ್ಫಾರ್ಮೇಶನ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಔಟ್ ಆಫ್ ದೀಸ್ 2 to the power of n number of select lines, n number of input lines, one input line will be selected at any time. Okay, this is the logic symbol here. You can see here I can have 2 to the power of n data input lines, that is d0, d1, d2, d3, d so on up to dn minus 1. So totally like this I can have the 2 to the power of n input lines. So as I already told you, while writing the logic symbol, it is a good practice to write the inputs at the left side and output at the right side. So as I told you, this is a system, logic system, which consists of 2 to the power of n input lines, and there is a single output. Why, you can see here there is a single output, and there are n number of select lines are here. So as I told you, this is a system which consists of 2 to the power of n input lines, one output line, and n number of select lines. So here in the logic symbol you can see an additional pin here, that is enable input here. So what is the use of this enable input? So as we already know, for many electrical systems there will be an on and off switch will be there. Let's say if you want to get the functionality out of the that electrical device, first thing, the primary thing that you will make is you will switch on the power. If you don't switch on the power itself, then you cannot get the functionality out of that electrical device, or whatever the logic device or whatever. Illi kuda this works like an on and off switch. So let's say if this system itself is not enabled andaga, this is not going to function anything. First and the primary thing is you have to enable this system. In order to make, or in order to enable, or in order to switch on this system, first thing is you have to activate this enable input. ಈ enable input na ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ನಾವು activate ಮಾಡಬೇಕಾಗುತ್ತೆ. Like this, in logical symbol you can say there will be 2 to the power of n input lines, one output line, and these are the n number of select lines, and there will be another enable input. Okay, so these multiplexers, they come in different variations. As I told you, general system is represented using 2 to the power of n is to 1 with n number of select lines. Okay, so if you substitute n equal to 1, then you will get 2 to the power of, so 2 is to 1 mux. So number of select lines, yes sir, obviously number of select lines will be n number of select lines. So with n equal to 1, I can get this system. Means there will be only one select line will be there, and there will be two inputs and one output. For n equal to 2 here, for n equal to 2, you will get a different variation in the multiplexer system, that is 4 is to 1. In 4 is to 1 marks, there will be 4 inputs and single output, and n number of select lines andre there will be 2 select lines. Similarly, with n equal to 3, I can get 8 is to 1 mux. With n equal to 4, I can get 16 is to 1 mux. And with n equal to 5, I can get 32 is to 1 mux. Like this, these multiplexers, they are available in market with the different variations. First, we shall discuss the very first variation, that is 2 is to 1 mux. In case of 2 is to 1 mux, as I told you, there will be two input lines. There are two inputs and one select line, and this content of this select line is going to tell you which input line is to be selected. And whenever a particular input line is selected, the information on that input line is routed on a single output line. Let us consider the d0 and d1 are the input lines or input variables. You can rename, or you can name it in any fashion. You can rename it as x and y, whatever. d0 and d1 be the input lines, and s be the select input, and e be the enable input. and y be the output. So you can see here logic symbol is shown here. Logic symbols are usually shown with the square box. At the left hand side you have to show the inputs, and at the right hand side you have to show the output. Here you can see here D0 and D1 are the inputs, and E will be the enable input, and there is a single select line input, and this is an output here. How it works? So based on the select input here, if select input is 0, so with single input combination I can have two possibilities. So as we know that from the first semester in the digital electronics, we have seen that with n inputs I can have 2 to the power of n combinations, different input combinations. For example, if n equal to 1, if you substitute n equal to 1, then I can get 2 to the power of n is nothing but 2. With n equal to 2, I can get 4 different combinations, and with n equal to 3, I can get 8 different combinations, and like it goes on. With single input, with n equal to 1, I can have two possibilities. The two possibilities are 0 or 1. So if the select line input is 0, so obviously the information on this select line is going to tell you which input line is selected, and the information is routed on the output line. Okay, so ಇಲ್ಲಿ s equal to 0 ಇದ್ರೆ, so obviously if s is equal to 0, the first line is selected. As I told you, at any instant only one input line is selected. With s equal to 0, d0 is selected. So let's say d0 is selected andaga, the information on this d0 pin, the information on the d0 pin, it may be 0 or it may be 1, right? So if it is 0, then 0 is routed to y. If it is 1, then 1 will be routed to the output line y. So if s is equal to 0, then d0 is selected, and the information, whatever the information on the d0, that is 0 or it may be 1, is routed on the output line y, right? Similarly, if s is equal to 1, if s is equal to 1, then the second line has to be selected. Second line in the sense that is d1 is selected, and the information on the d1 is routed on the output line y. So you have seen the both cases here. With s equal to 0, the information on the d0 is routed on the output line y, and with s equal to 1, the information on d1 is routed on the output line y. Then what is the importance of enable here? As I told you, so this is the information, or this is the input which will either enable or disable this system. So here I can have different types of enabling systems here: active high or active low enabling systems. So here I have shown with an arrow here, and I have simply written it as E here. E in the sense, this is simply if I have not written any bar, means this is an active high pin. Active high pin in the sense, so whenever I provide an input 1 on this pin, whenever I provide an input 1 on this pin, this logic system is going to be enabled. And if I provide logic 0 on this pin, this is going to disable the system. So whenever I enable the system, then I can make a selection of these two inputs based on the select input. Means for this operation, I have to give an active high signal on this enable pin. If I give an active low signal on this enable pin, the entire system itself will be disabled. The content of the select lines doesn't make any effect on this system here. So system ಏನಿರುತ್ತೆ, 1 ಕೊಟ್ಟಾಗ system on ಆಗುತ್ತೆ. System on ಆದಾಗ, ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಿ ಸೆಲೆಕ್ಟ್ ಇನ್ಪುಟ್ 0 ಅಥವಾ 1 ಅನ್ನು ನೋಡ್ಕೊಂಡು ಔಟ್ಪುಟ್ ಯಾವುದಾದ್ರೂ d0 ಅಥವಾ d1 ಔಟ್ಪುಟ್ ಲೈನಿಗೆ ಬರುತ್ತೆ. ಸಪೋಸ್ ಎನೇಬಲ್ನೇ 0 ಮಾಡಿಬಿಟ್ಟಿದ್ರೆ, ಸೊ ಸೆಲೆಕ್ಟ್ ಇನ್ಪುಟ್ ಏನಾದರೂ ಇರಲಿ ಔಟ್ಪುಟ್ ಏನು ಬರಲ್ಲ. ಔಟ್ಪುಟ್ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ, 0 ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಸಿಸ್ಟಮ್ ಏನಾಗಿರುತ್ತೆ, ಡಿಸೇಬಲ್ ಆಗಿರುತ್ತೆ. So here truth table, you can clearly see the operation here. E and S are the inputs. E andre enable, S andre 0. So with two inputs, as we know from the previous semester, we can simply write the four different combinations that are 0 0, 0 1, 1 0 and 1 1. So for the first two combinations, enable is 0 here. If enable itself is 0, as I told you, the total system itself will be in the disable condition. ಅಂದರೆ ಇದು ಸಿಸ್ಟಮ್ ಏನಿರುತ್ತೆ, ಆಫ್ ಇರುತ್ತೆ. ಆವಾಗ ಐ ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್ ಯು, ದ ಕಂಟೆಂಟ್ ಆಫ್ ಸೆಲೆಕ್ಟ್ ಇನ್ಪುಟ್ ಡಸಂಟ್ ಮೇಕ್ ಎನಿ ಎಫೆಕ್ಟ್ ಆನ್ ದಿ ಔಟ್ಪುಟ್ ಲೈನ್ ಹಿಯರ್. ಮೀನ್ಸ್ ಎಸ್ 0 ಇರಲಿ ಅಥವಾ ಎಸ್ 1 ಇರಲಿ, ಔಟ್ಪುಟ್ ಏನಿರುತ್ತೆ, ಫಾರ್ ದೀಸ್ ಟು ಕಾಂಬಿನೇಷನ್ಸ್ ದ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ 0. For the next two combinations, you can see the enable pin is 1 here. So with enable equal to 1, then I can make a selection out of these two inputs based on the select line input. If select line is 0, first combination ನೋಡಬಹುದು ನೀವು, select line 0 ಇದ್ರೆ ಏನಾಗಬೇಕು, D0 select ಆಗಬೇಕು, and the content of D0 will go on to the output line Y. So ಇಲ್ಲಿ Y equal to ಏನಾಗುತ್ತೆ, ದ D0 ಅಂತ ಆಗುತ್ತೆ. ಸೊ ಕೇಳಬಹುದು ಈಗ D0 ಅಂದ್ರೆ ಏನು ಸರ್ ಅಂತ. ಸೊ D0, it may be 0 or it may be 1. We won't specify whether it is 0 or 1. We will simply tell the information on the D0 will be simply routed on the output line Y. That's it. Similarly, if S is equal to 1, S is equal to 1 ಅಂದ್ರೆ select line ಏನಾದರೂ 1 ಆಗಿದ್ರೆ, I already told you that D1 is selected and the information on the D1 will be routed on the output line Y. So ಅದಕ್ಕೆ ಇಲ್ಲಿ ಏನು ಬರ್ದಿವಿ, D1 ಅಂತ ಬರ್ದಿವಿ. Or else you can simplify the truth table. ಇನ್ನೂ ಕೂಡ ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಬೋದು. ಹೇಗಪ್ಪ ಅಂದ್ರೆ, hope you have heard about this term. This is don't care. Don't care in the sense, it may be 0 or it may be 1. That doesn't make any effect ಅಂತ ಅರ್ಥ. This is nothing but don't care. ಇಲ್ಲಿ ನೀವು ಇಂಗ್ಲಿಷ್ ಸೆಂಟೆನ್ಸ್ ನಲ್ಲಿ ಹೇಳ್ಬೇಕಾದಾಗ ಒಂದು ಮಾತು ಹೇಳ್ಬೋದು. If enable pin itself is 0, if enable pin is itself is 0, then the system doesn't care what is the information on the select line. 0 ಇರಬಹುದು, 1 ಇರಬಹುದು, output will be 0. These two combinations can be replaced with a single combination. ಹೆಂಗ್ ಬರಿಬಹುದಪ್ಪ ಅಂದ್ರೆ, enable 0 ಇದ್ದು whatever may be the content, means we don't care about the select line content and the output will be 0. So this truth table can be rewritten as 0x0 for the first two combinations, and for the rest two combinations, as I told you, one for selection, if select input is 0, then output will be D0, and if select input is 1, then it will be D1. Now I want to write the logic expression for output Y. So how do you write the logic expression? One way is to reduce using the Boolean laws, or using Boolean laws, you will get an SOP equation. Or another way is to write the logic expression using KMap. So since it is a two variable, there are two variables in the truth table, and obviously it will be a 4 cell KMap will be there. Andre with n inputs ನಿಂದ 2 to the power of n cells ಇರ್ತವೆ KMap ನಲ್ಲಿ. So ನೋಡಬಹುದು, there are 4 cells. So as we know that at one side I will write E, another input, that is S will be written here 0 1 and 0 1. This cell will be for the first combination, that is with 0 0, with 0 0, first output is 0 0 is written here. With 0 and 1, with 0 1, output is again 0, so 0 is written here. And with 1 0, with 1 0 combination I can get the output D0, so D0 is written here. And with 1 and 1 combination I get an output D1, and D1 is written here. Now I have to make the groupings. So in groupings normally ಏನಾಗುತ್ತಪ್ಪ, ನೀವು ನೋಡಿರ್ತೀರಿ 0 1's combinations ಇರ್ತವೆ. This is a special type of KMap here. ಇಲ್ಲಿ ನೀವು ನೋಡಬಹುದು D0 and D1. So usually groupings ಯಾವಾಗ ಮಾಡ್ತೀರಾ, whenever there are similar neighboring cells you are going to find, then you will make a group of single cell, or you will make a group of 2 4 8 16 whatever. First thing is you have to find the is there any possibility to group the large number of cells ನೋಡ್ತೀರಿ large number of neighboring cells ನ ಗ್ರೂಪ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗತ್ತಾ ಅದೆಲ್ಲ ನೀವು ಕಲ್ತಿರ್ತೀರ ಫಸ್ಟ್ ಇಯರ್ ನಲ್ಲಿ. So here you can see there are these are the two neighboring cells d0 and d1 and these are not same, so same illa you can make the single group here d0 and d1. First group ಗೆ ಏನು ಕಾಂಬಿನೇಷನ್ ಆಗುತ್ತಪ್ಪ ಅಂತ ನೋಡಿದಾಗ you have to multiply the cell content ಏನಿರುತ್ತೆ ಅದು row value and column value. So ಎಲ್ಲಾನು multiply ಮಾಡಿದಾಗ you will get a product. So how many such groups are there, then you have to add them. So ಎಲ್ಲಾನು ಏನು ಮಾಡಬೇಕಾಗತ್ತಾ ಸಮ್ ಮಾಡಬೇಕಾಗತ್ತಾ. So and that equation is nothing but SOP equation ಅಂತ ಕರೀತಾರೆ, that is sum of products. Each group is going to result a product and you have to make or you have to add such groups to get a SOP equation for the output. So here you can say first group ಇಲ್ಲಿರೋದು, what is the row value here 1 ಅಂದ್ರೆ E ಐತೆ. ಸೊ E ಏನಿರುತ್ತಾ ಅದನ್ನ ತಗೋಬೇಕಾಗತ್ತಾ, E ಅಂತ ಬರ್ಕೊಂಡ್ರಿ. ನೆಕ್ಸ್ಟ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಕಾಲಮ್ ವ್ಯಾಲ್ಯೂ ನೋಡ್ಬೋದು, ದಿಸ್ ಇಸ್ 0 ಅಂದಾಗ that is indicated by bar variable, over that we will write a bar. ಸೊ ಎಸ್ ನ ಏನ್ ತಗೋಬೇಕಾಗತ್ತ, ನಾನು ಎಸ್ ಬಾರ್ ಅಂತ ತಗೋಬೇಕಾಗತ್ತ. E into S bar multiplied with ಸೆಲ್ ಕಂಟೆಂಟ್ ಅಂತ ಹೇಳಿದೆ. ಸೆಲ್ ಕಂಟೆಂಟ್ ಏನಿರೋದಲ್ಲಿ D0, ಸೊ D0 ಅಂತ ಬರ್ಕೋತಾರೆ. ಸೊ ಫಸ್ಟ್ ಕಾಂಬಿನೇಷನ್ ಏನಾಯ್ತು ಇ ಎಸ್ ಬಾರ್ D0. ಸೊ ನೀವು ಯೂಸಲಿ ನೋಡಿರ್ತೀರ ಎಲ್ಲಾ ಕಡೆನೂ ಪ್ರಾಡಕ್ಟ್ ಇಕ್ವೇಶನ್ ಬರಿಬೇಕಾದ್ರೆ ಹಿಂಗೆ ಬರೀತೀರಿ. ಏನೇನ್ ಮಾಡಬೇಕು, ರೋ ವ್ಯಾಲ್ಯೂ ಇಂಟು ಕಾಲಮ್ ವ್ಯಾಲ್ಯೂ ಇಂಟು ಸೆಲ್ ಕಂಟೆಂಟ್. ರೋ ವ್ಯಾಲ್ಯೂ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಕಾಲಮ್ ವ್ಯಾಲ್ಯೂ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ದಿ ಸೆಲ್ ಕಂಟೆಂಟ್. ಇಲ್ಲಿ ಸೆಲ್ ಕಂಟೆಂಟ್ D0 ಇರೋದ್ರಿಂದ D0 ಅಂತ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾರೆ. ಪ್ಲಸ್ ದಿಸ್ ಇಸ್ ಒನ್ ಪ್ರಾಡಕ್ಟ್. ಓಕೆ, ಫಾರ್ ದಿ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ನೀವೇ ನೋಡಬಹುದು. ಈಗ ವಾಟ್ ಇಸ್ ದ ರೋ ವ್ಯಾಲ್ಯೂ 1, that is E. What is the column value 1, that is S. E into S into D1. So E multiplied by S multiplied by D1. So this is another product and these two products have to be added. So finally ಏನಾಗುತ್ತೆ SOP equation, sum of product equation ಅಂದ್ರೆ this is the first product and this is the second product. So if there are multiple groups are there, then you will get the multiple products and all those products have to be added. So this is an SOP equation, E S bar D0 plus E S D1. Remember all the product terms, there is a logic gate which will does the product operation. So ಯಾವ್ದಪ್ಪ ಅದು AND gate, and there is a logic gate that is meant for addition, ಯಾವ್ದದು OR gate. So all the SOP equations are usually implemented using the logic gates AND gate and OR gate. And here in some terms you will be getting bars here. Bars ಅಂತ ನಂಗೆ ಗೊತ್ತಾಗತ್ತಾ, ಬಾರ್ಸ್ ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ನೆಗೇಷನ್ ಅಂತ ಅರ್ಥ. ಸೊ ಅದನ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನನ್ಗೆ ಏನ್ ಬೇಕಾಗತ್ತಾ, ನಾಟ್ ಗೇಟ್ ಅಂತ ಬೇಕಾಗತ್ತಾ. ಮೀನ್ಸ್ ಟು ಸೇ ದಟ್ ಆಲ್ SOP equations are implemented using the basic logic gates that are not gate, AND gate and OR gate. ಆ ಫಂಕ್ಷನಾಲಿಟಿನ ಇಲ್ಲಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ನೀವು ನೋಡ್ಬೋದು. ಸೊ D0 ಇಲ್ಲಿ ಫಸ್ಟ್ ಒಂದು AND ಗೇಟ್, ದಿಸ್ ಇಸ್ ಫಾರ್ ಪ್ರಾಡಕ್ಟ್ 1. ಫಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ಗೆ ಇದು ಇರೋದು AND ಗೇಟು. ಸೆಕೆಂಡ್ ಪ್ರಾಡಕ್ಟ್ಗೆ ಇನ್ನೊಂದು AND ಗೇಟ್ ಇರೋದು, ದಟ್ ಈಸ್ AND gate here. And here remember I need actually in the diagram I have not shown, but actually here we need an 3 input AND gate, not 2 input AND gate. We need 3 input AND gate. So D0 ಅಂತ ಒಂದು ಟರ್ಮ್ ಬಂತಿಲ್ಲಿ, ಫಸ್ಟ್ ಟರ್ಮ್ ನೋಡ್ರಿ D0 ಬಂತು. ನೆಕ್ಸ್ಟ್ ಎಸ್ ನ ಇನ್ವರ್ಟ್ ಮಾಡಿದ್ದಾರೆ, ಎಸ್ ನ ಇನ್ವರ್ಟ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತಾ, ಎಸ್ ಬಾರ್ D0 S ಬಾರ್. ಇದಕ್ಕೆ ಏನ್ ಬೇಕು, ಇನ್ನೊಂದು ಇ ಅಂತ ಒಂದು ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಬೇಕು. So let's take one more signal here, that is E. So first gate ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಬೋದು. ಫಸ್ಟ್ AND gate it consists of 3 inputs ಯಾವ್ಯಾವು, D0, E and S bar. E S bar D0 ಫಸ್ಟ್ ಟರ್ಮ್, ಫಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಇಲ್ಲಿ ಬಂತು, ಫಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಬಂತು. ಸಿಮಿಲರ್ಲಿ ಸೆಕೆಂಡ್ ಪ್ರಾಡಕ್ಟ್ ನೋಡ್ರಿ, E S D1 ಅಂತ ಇದೆ. ಸೊ ಸೆಲೆಕ್ಟ್ ಇನ್ಪುಟ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ತೊಗೊಂಡಿದ್ದಾರೆ. ಎಸ್ ಇಲ್ಲಿ ಬಂತು, D1 ಇಲ್ಲಿ ಬಂತು. ನೆಕ್ಸ್ಟ್ ಅದೇ ಇಲ್ಲಿ ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತೀನಿ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಸೆಕೆಂಡ್ ಪ್ರಾಡಕ್ಟ್ ಯಾವ್ದು ಬಂತು, ES D1. Now these two products have to be added. So addition ಮಾಡಲಿಕ್ಕೆ we have an OR gate here. Obviously this OR gate is going to add these two products, P1 plus P2 ಆಗುತ್ತೆ. Finally we will get the SOP equation, ES bar D0 plus ES D1. Okay. Next we will move on to the second variant of multiplexer, that is 4:1 marks. 4:1 marks ಅಂದ್ರೆ obviously ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, there will be 4 input lines and 1 output line and n number of select lines. There will be 2 select lines will be there. Based on the information on these 2 select lines, one of the 4 inputs will be selected at any time and its information is routed on the single output line. Let us consider the D0, D1, D2 and D3 as the input variables, S0 and S1 as the 2 select lines and E with the enable input. So let's see the operation first here. So as you can see, there is an enable input here and these are the 4 inputs which are designated as D0, D1, D2 and D3, and there is a single output line Y and there are 2 select lines S1 and S0. So with S1 and S0 ನಮಗೆ ಗೊತ್ತು, with the 2 input variables I can have 4 different combinations. 4 different combinations ಅಂದ್ರೆ ಯಾವ ಬರ್ಬೋದು, 0 0 0 1, next 1 0, next 1 1. So based on this select line information, one of the inputs will be selected at any time, correct? So let's say as we discussed about the enable signal, this is an active high signal. Andaga this should be always set to 1. If it is set to 0, then this total system itself will be disabled and output will remain always 0 irrespective of the content of select line. So let us assume that it is connected to VCC or it is connected to 1 and the system is enabled now. Now once the system is enabled, now the system will look for the content on the select lines. First combination nodre, with 0 0, with 0 0 ಯಾವ line select ಆಗಬೇಕು, D0 is selected and the content on D0 will appear on output line Y. With 0 1, with 0 1 ಯಾವ line select ಆಗಬೇಕು, the second line, that is D1 is selected and its information will appear on Y. With 1 0, third combination, the information on D2 will appear on output line Y, and with last combination, that is 1 1, then the final output or final input line, that is D3 is selected and its information will be routed on the output line Y. Right, this is the operation, very similar to the previous case. Let's see the truth table here. Information input ಯಾವ ಬರ್ತಾವಪ್ಪ ಅಲ್ಲಿ, E S1 and S0. For the first 4 combinations I can write, with the 3 input combinations I can write 8 different possible combinations here. ನೀವು ನೋಡಿರಬಹುದು, with 0 it starts from 0 0 0 and it goes until it becomes 1 9 1 1 1. So if you see, if you observe the truth table here, for the first 4 combinations, the enable pin is 0. Enable input is 0. As I already told you, this is an active high enable input pin ಅಂದಾಗ ಇದಕ್ಕೆ 1 ಕೊಟ್ಟರೆ ಮಾತ್ರ ಏನಾಗುತ್ತೆ, ಸಿಸ್ಟಮ್ ಎನೇಬಲ್ ಆಗುತ್ತೆ. 0 ಕೊಟ್ಟರೆ ಸಿಸ್ಟಮ್ ಏನಾಗಿರುತ್ತೆ, ಡಿಸೇಬಲ್ ಆಗಿರುತ್ತೆ. ಇದರ ಅರ್ಥ, if enable itself is 0, whatever may be the content on the select line, enable 0 ಇದ್ರೆ ಸಿಸ್ಟಮ್ ಡಿಸೇಬಲ್ ಆಗಿರೋದ್ರಿಂದ ಏನಾರ ಕಂಟೆಂಟ್ ಇರಲಿ, ಔಟ್ಪುಟ್ ಏನಿರುತ್ತೆ ಯಾವಾಗಲೂ 0ನೇ ಇರುತ್ತೆ. So I can replace these 4 combinations. With a single combination. ಹೆಂಗ್ ಬರಿಬಹುದು? So input 0 ಇದ್ದು, whatever may be the select line, I don't bother about the information on the select line. So that is indicated by XX, that is don't care. 0XX, the output remains 0. Andre these 4 combinations can be replaced with a single combination like this. Okay, next consider the 4 other different combinations, that is where the enable is 1. If enable is 1, system, whenever it is enabled, then it will look for the content on select lines with 0 0. And as I already told you, the first line, that is D naught, is selected and it is routed to the output line Y. Information on the D naught output bantu with 0 1 D1 bantu, with 1 0 D2, and with 1 1 D3. The same is rewritten here. Whenever the enable is 0, whatever may be the content on the select line, output will remain 0. And with enable 1, with S1 0 and 0, D naught is selected, first line is selected, and it is routed on the output line Y. And similarly for the last case, with enable 1 and with S1 and S0 both are 1 1, the last input line is selected and its information is routed on the output line Y. Now we shall try to write the Boolean expression for the output line Y using KMap. So as there are three input variables are there, I can have an 8 different combinations, and uh, I should have a KMap of which consists of 8 cells. E is taken here as the V acts as a row, and S1 S0 they acts as the columns here. So here numbering cells ನಿಮ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ. We will be using the gray code sequence here, 0 0 0 1 and 1 1 and 1 0. 0 ಇದ್ರೆ ಬಾರ್ ಅಂತ ತಗೋಬೇಕು, 1 ಇದ್ರೆ as it is the variable name ಹೆಂಗಿರುತ್ತೆ ಹಂಗೆ ತಗೋಬೇಕು. So we will make an entry as per the truth table. We make an entry here in the KMap cell. So for the first four combinations, that is for whenever enable is 0, uh, for the first four combinations, we make an entry 0 0 0. So as per the truth table, now 0 0 ಅಂತ entry ಮಾಡಿದೀವಿ. Next for the four combinations, we will write D0, D1, D2 and D3. So ಈ ತರ ಬರೆದಾಗ, sorry, so D0, D1, D2 and D3 ಅಂತ ಬರೆದಿದ್ವಿ. And here multiple groups ಅಂತ ಆಗಲ್ಲ, these all are different or unique combination ಇರೋದ್ರಿಂದ, so we will make a single groups ಅಂತ ನೋಡಿರ್ತೀರಿ. ಈಗ ಸಿಂಗಲ್ ಗ್ರೂಪ್ಸ್ಗೆ ನಾವು we have to write the SOP equation. SOP ಅಂದ್ರೆ sum of products equation. As there are four groups are there, means there will be four products, and all these four products are added. So first product ಏನಾಗುತ್ತೆ ನೋಡ್ಬೋದು ನಾವು ಇಲ್ಲಿ. If you write an product term for this one, ನಾ ಹೇಳಿದೀನಿ row content into column content into the cell content, correct? These three have to be multiplied. The row content has to be multiplied with the column content, and the same has to be multiplied with the cell content. E S1 bar S0 bar D0. E S1 bar S0 D1. E S1 S0 D2. E S1 S0 bar D3. And the same is written here. And finally, in order to get the SOP equation, all these product terms have to be added together. And this is the logic circuit which is going to implement the same functionality. So we'll write D0, D1, D2, D3, S1, S0 and E here. The first product term you can get here, that is E S1 bar S0 bar D0. So that is implemented using a 4 input AND gate, and you have to make a connection here. Then the second product term is implemented using another a 4 input AND gate, and the third one is implemented here, and the fourth product term is implemented, and all these four product terms have to be added together, and we need a 4 input OR gate. The final output is Y here. Okay, the next variation is an 8:1 mux. So here in case of 8:1 mux, there are totally 8 input lines and 3 select lines to select the data input lines, and there will be one output line. So you can see here there are 8 input lines and one enable signal and 3 select lines, and there is only one output line. From the truth table you can simply write whenever enable is equal to 0, enable pin 0 iddaga, whatever may be the content of the select lines, output will remain 0. And if enable, it becomes 1. So if it becomes 1, obviously we will look for the content on select lines. So if you don't write this ಅಂದಾಗ total ಎಷ್ಟಾಗುತ್ತೆ with 4 input I can get 16 different combinations. 16 different combinations reduce ಮಾಡಿ I can write simply 9 combinations like this. With enable equal to 1, then system will look for the select line contents, that is the content on A2, A1, A0. Okay, these should be A2, A1 and A0. Please make a correction here. Okay, with 0, 0, 0, the first line I0 is selected. With 0, 0, 1, I1 is selected. With 0, 1, 0, I2 is selected. 0, 1, 1, I3, like this. So with 1, 1, 1, the final input line, that is I7 is uh, I7 is selected, and its information appears on the output Z. Okay, and here we are supposed to write the kmap of 16 cells, and the same way what we have followed in the previous two variations, in the similar sense, we are supposed to write an SOP equation which consists of 8 product terms, and all those 8 product terms have to be added, and finally we will get an output, that is Z here. This thing you can try out in your home. Okay, thank you.